Okay guys, welcome to the second video. Here we start talking about gross future loss random variable. Okay, so as usual, this is basically the random variable that defines the insurer's loss. But in addition to that, what we are introducing here newly are expenses. Okay, so we are also incorporating expenses into the net future loss random variable in order to make it gross future loss random variable, right? So let us start with this concept. Let's first define a few notation in addition to what we have already discussed. Okay, so I is the initial expense that is incurred on a contract. Okay, so we'll be denoting the initial expense as I. E is the level annual expense that is payable every year. Okay, so this is payable at the outset of the contract and this is payable at the beginning of every year along with every annual premium. Okay, and lastly there is F. Okay, this is your termination expense, or this is usually called as claim expense. So we have got these three types of expenses, new expenses that we have to incorporate in the gross future loss random variable. Okay, so let us start talking by taking an example. Okay, let's consider a whole life assurance which pays S pounds. Okay, S pounds at the big whenever a person dies. Okay, so your benefit amount is S. Okay, and let the gross premium that is charged for this contract be G. Okay, so this is your gross premium. We'll be learning the calculation of gross premium soon. How do we calculate it? Let's just use this notation for now. Okay, and as I defined the three notations just now, let I be the initial expense, let E be the expense that is level payable annually, level expense, level annual expense, and let F be the termination expense. So let's try to picturize this. What is happening here? See, what I'm telling you is there is this person, he buys a whole life assurance contract and he will be getting an amount of S whenever at the end of the year when he dies. Okay, so this is obviously payable at the end of the year of death. Okay, so if he dies at time 1 he gets S at time 1, if he dies at time 2 he gets S at time 2, and so on and so forth, right? Okay, so that's the deal. And there are level premiums G, G, G every year. They are payable every year. Along with these level premiums, with the first year's premium, there is an expense I, and with every subsequent premium, there is an expense of E. Okay, and whenever this guy he dies, he is getting a sum assured of S, plus he'll be plus there will be a expense of F incurred by the company in order to process this claim. Okay, so that is the deal uh, we are um, processing here. Okay, so let's try to define the gross future loss random variable. Okay, so what is the definition of the gross future loss random variable? It is the PV of the um, loss would obviously be benefits minus premiums, right? Because loss would only occur if benefits are more than premium. So PV of benefits minus the PV of premiums, not the expected present value, the PV, that is the present value random variable. There would be one more thing here, PV of expenses, that would be added to the PV of benefits. So this is your gross future loss random variable now. Okay, so in order to determine this, let's start writing what we have. Okay, so your PV of benefits would be S into V to the power of kx plus 1, right? That would be your PV of benefit, because That's the usual notation for the discounting factor that we use for benefits, and S is your amount of benefits, right? So it would be discounted by kx plus 1 because it is payable at the end of the year of death. Cool. Then the PV of premium would be same as before, G this time. We are not using the standard notation P that we use for net premium, but we use the gross premium that is calculated including the expenses too. So G into A due kx plus 1. These are the premiums that are payable at the beginning of every year, and since they are payable from time 0, so it is kx plus 1, right? So this is same as always, okay? Additionally, I have expenses. So the PV of the initial expense is obviously I, okay? So that is something I have. The PV of the annual expense. Now this one is tricky. It is E into A due kx plus 1 minus 1, because for the reason that it is not payable in the first year, it is payable on the in all the subsequent years. So I have got A due kx plus 1 as always. I just deduct minus 1, or I could have taken E into A kx instead. This notation could also be used, okay? So you could use either of the notation, or E due kx plus 1 minus 1, or E into AKX, right? Plus, I will have one more thing, because since now these expenses would be payable in arrears, so they would be payable at time 1, at time 2, 3, 4, and so on and so forth. So I can also use this notation. And I have one more thing, F, that is payable at the time of death. So that is VKX plus 1, right? So this is your gross gross future loss random variable. Let me write it clearly. It is S plus F, okay, into V to the power of kx plus 1 into I minus E, okay. I'm just multiplying this thing inside and taking this minus E separately, plus this F is considered, okay. We have got I and E, everything is taken. Only two things that remain are this E into A due kx plus 1 and this G into A due kx plus 1. So what I do here is G minus E into A due kx. So I've just jumbled these things up. You try and do it by yourself. You'll get the same result. Okay. So this is my gross future loss random variable for such a contract. This makes sense too. This is your aggregate amount that is payable on claim, that is the death benefit plus the claim expense, okay. This is your I minus E is your amount that is payable extra at the outset over and above the normal claim expense. So this is something you have. So this is your initial expense, extra initial expense, let me call it extra initial expense, okay. And this G minus E is your annual premium minus your regular expense. Since I will be paying this premium, I'll be paying this expense out of every year's premium. This is also deducted from the premium, right? Premium is an inflow, expense is an outflow for the company. So that's how it works. Or you could have just left this gross future loss random variable here at this step itself, okay. You don't need to even get here, okay. You don't need to get here because it is very obvious. I just did it to intuitively explain things to you, okay. So let's talk about another contract. Now let's just say instead of this these benefits which were payable at the end of the year of death, now I can have benefits that are payable um, at the time of death, okay, immediately. So I have immediate benefits now. And instead of these premiums, okay, which are payable in advance, let's take continuous premiums. Okay, and let us consider that the expenses are also payable continuously. Okay, so this is the new example I have, that the expenses are also payable continuously. So makes sense, right? So what would be the gross future loss random variable? It would be EPV, would be the present value random variable, gross present value random variable for your benefits plus your expenses minus the present value random variable for your premiums. That is what it would be. So for the benefits, I would have S into V to the power of Tx this time, because these are payable exactly at the time of death. So no Kx, Tx. Okay, we have got Tx instead of the Kx. And what I would have are the expenses, initial expenses I. Okay. Uh, Expenses that are payable every year along with the premium are now E. Okay, so these are payable continuously with the premium, so that becomes E into A continuous TX. Okay, uh, and I have got expenses that are payable at the time of death, that is the benefit or the termination expenses, that is F into V to the power of TX, same as this. Okay, minus the premium would obviously be G into A continuous TX. So that's your gross future loss random variable. See, it's easy to define, right? For any kinds of contracts, you can actually define it directly, right? Makes a lot of sense. So yeah, that's it. Okay, now let's just try the same thing for an endowment assurance contract. Okay, so what we're trying is endowment assurance, and what we are calculating is the gross future loss random variable, right? So let's try this. So what would be the gross future loss random variable if there is an endowment assurance of an amount S, where all the previous notations are used and the premium is G and everything, and the benefits are payable at the end of the year of death, or um, or your survival, or at survival. Okay, so that's the question. So let's see. So it would be a benefit, that is S into V to the power of minimum of, now we have a minimum of kx plus 1 comma n, obviously, because if kx plus 1 is less, then the benefit is payable at the end of the year of death, that is if he dies before time n, it is payable at the end of the year of death. And if n is less, then it is payable at time n, right, if he survives beyond time n. Cool. So this is your death benefit plus your initial expense, that is I, plus E, that is the annual expense, into A due minimum of kx plus 1 comma n minus 1, because this is not payable in the first year. Makes sense, right? Plus the claim expense, that is F into V minimum of kx plus 1 comma n, okay, minus G into A due minimum of kx plus 1 comma n, because this is payable in advance for n kx plus 1 years or n years, right? So this would be your gross future loss random variable in this case. Okay, so this is question number 7.7, a bit tricky one. So it says write down an expression for gross future loss random variable for a deferred life annuity. Okay, so we have a deferred life annuity which is deferred by a period of n years, and the premium of amount G are payable annually in advance for a maximum of n years. Okay, so the premiums are payable for a maximum of n years, and then the benefit starts in payable in advance. Okay, from n years onward. Okay. The annuity benefit of B is paid for the life annually in advance, starting in n years time. Okay, so they have got this benefit which is payable starting in n years time, and no benefit is paid if the life does not survive to time n. Okay, so there is no benefit if the life does not survive to time n. State any other assumptions that you make and define the other symbols that you use. So I'm going to use the symbols as they have used in your core reading. Okay, your answer there, so that you don't get confused. So I'm going to define the first other symbols first. I be the initial expense, initial excess expense basically. Okay, because they're saying that this I is the initial excess expense over the normal expense which is payable. So what they are telling us is that I is the I plus E is the amount of expense payable at time 0, and from this time onwards the expenses E and E and E and E and so on. Okay, so I is the extra amount of expense at time 0. Usually what we had so far was the notation we used so far, I was the total expense. This entire expense was denoted as I, but now they have denoted I as the initial excess expense. We can also use this. Okay, so we are using this, we are taking I to be the initial excess expense. E is the annual level expense. Okay, which is payable with the premium. And they have defined another notation E dash, which is the annual claim expense, which is payable with the claim annuity amount. So annual claim expense, right? So they have used these notations, and I am going to use the same. Cool. Now let's just calculate the gross future loss random variable. So it is the EPV of the benefit. So the EPV of the benefit would be, and one more thing, they've taken one more symbol here. Let's check if the question stipulates it or not. Okay, yeah, they've stated that B is the amount of benefit, annuity benefit that is payable every year. So it is your EPV of the benefit plus the EPV of the expense minus the EPV of the premium. So one thing you should know for such contracts where there are such complicated payments, what you can do is you can divide the term into two parts. Okay, so let's see how we do that. So the net future loss random variable is equal to, it is divided into two parts. The two parts are when kx is less than n and when kx is greater than equal to n. And the reason I did it this is because see, your premiums are only payable till time n. Okay, and your benefits are only payable from time n. Okay, so if this person dies here, there are no benefits, and if this person dies here, there are no premiums, right? So it makes sense if we differentiate these. So although you can make do it in a single statement like they have done in the question, they've given you an alternative method, but this is the best method. This simplifies things a lot. Okay, so now let us consider the case where the person dies before time n. Okay, so we are only considering this half of the question. So what is payable here? We have got an initial expense I, okay, plus we have got an annual premium, that is A due kx plus 1. Okay, and since kx is less than n, we don't need to write that minimum of kx plus 1 comma and blah blah, none of that, because we know that kx is less than n here. So A due kx plus 1, that is your expense that is only payable till time n. Okay, makes sense. Now plus minus the amount of premium, so that is g into A due kx plus 1. Again, we don't need to use the minimum thing because we have already separated this into two parts. If he survives beyond time n, if this guy survives beyond time n, what is your amount of net future loss random variable? Okay, so now your initial expense was paid at time 0. Yes, it is the same. Plus, what is your amount of these expenses which were payable with the premium? They become E into A due n. That becomes simple because see, you have only these expenses payable till time n and not after that, so it becomes A due n minus g into again A due n. This simplifies too because the premiums are only payable till time n. Plus, now this changes. Now I've got the benefit that is B, and it is payable time n onwards, right? It is payable time n onwards. So this amount of benefit is into B into A due kx plus 1 minus n. The amount of years are reduced by a factor of n, because if this person dies, let's say at between time n plus 1 and n plus 2, his curate lifetime becomes n plus 1. Okay, and the total amount of annuity benefits that would have been paid to him would have been 1 at time n, because these are payable in advance, and 1 at time n plus 1, so it is 2. So kx plus 1 would be n plus 2, minus n would be minus n, and it becomes 2, right? So it's verified. We can use this, right? And this b, it would once I have taken this, it needs to be discounted back till time 0, right? So there is a factor of Vn along with it. Might confuse you, but think about it. Very logical. Okay, so Vn is a factor. Apart from this, we would have the annual expense, which would be E dash into A due, same as this, Kx plus 1 minus n into Vn, right? So this is your net future loss random variable if if Kx is greater than n. So I just separated it into two parts, and you can do it like this. So this is good. Think about it. It makes sense. Okay, so the next thing we start with is arguably one of the most tricky topics of subject CT5. So I'm going to go really slow and explain things step by step. I hope you get it. If you don't, just rewind the video and try to watch it again. I'm sure you will get it. I'll explain it in such a way. Okay. So the topic is called as percentile premium, or the pet name for it is the easier name is calculating the premium that satisfies probabilities. Okay, so what's happening here? Let's see what's happening here. So far, when we used to talk about premiums, be it net premiums, or when we would be talking about gross premiums, what we usually do is we take an equation of value. We take an equation of value such as the expected present value of the sum assured plus maybe the EPV of expenses um, if I'm talking about the gross premium, and I equate it to the EPV of the premiums, right? And that's how I calculate my premiums, and I use this equation in order to find the value for the premium, right? The annual premium. But there is another approach that insurance companies use. Okay, what the approach is, it goes like in the question, they'll tell you that they want the probability of incurring the loss, okay, the probability of loss, of making a loss or getting a certain amount of profit has to be greater than or less than a certain level. So they might tell you that they want the probability of loss to be less than 5%, okay, or they want the probability of profit to be greater than 98%, okay, similar things like these. Okay, so these are basically counters of each other. If the probability of making a profit is 98%, the probability of making a loss would be 2%. Okay, so that makes sense, right? So they can give you such criterias, and they would ask you, based on these criterias, you have to calculate the amount of premiums. Okay, for this I have an example in order to explain this how things work here. Okay, the basic idea behind this is that we do not want the loss to exceed, the probability of incurring a loss to be more than a certain level, or we want a minimum probability for a profit. That is the basic idea behind these things. Okay, let's look into how we do it. So this is the simplest kind of example for such a contract, and this is given on uh, page number 10 of your core reading. Okay, so this is from page 10 of your core reading, and we are going to discuss it right now. Okay, so let's discuss this. So it says that a whole life assurance pays a sum assured of 10,000. Okay, they haven't given the currency. They're saying that the sum assured is 10,000 at the end of the year of death of a life aged 50 at entry. So there is a life who's aged 50 at the entry, and he's taking a whole life assurance policy, and the benefit is 10,000. Okay, whenever he dies at the end of the year of death, makes sense. And assuming a 3% per annum interest and AM92 ultimate mortality. So these are the criteria. See, the interest is 3%. Now we cannot work with the tables here, right? Because tables are only given for 4% and 6%. So they have given this criteria and AM92 mortality. Okay, and the expense level is 4% for of every premium. Calculate the smallest level annual premium payable at the start of each year. Okay, so we want to calculate the annual premium payable in advance. That will ensure that the probability of making a loss under this contract is not greater than 5%. Okay, so that's their criteria. Okay, so since we are determining the amount of premium here, we are obviously at time 0 now, and this guy is age 50, and he has taken a whole life assurance policy with premiums payable throughout the life. Okay, so that's the deal. Okay, and the benefits are payable at the end of the year of death, and the premiums are payable in advance. So at time 0, when we are determining this premium, the loss, the amount of loss can be represented as a variable, a random variable, that is the net future loss random variable. So let's call that L0 since we are at time 0, and that would be equal to 10,000. That is your amount of benefit V to the power of kx plus 1 minus the present value of premium. Since we have no expenses in this question, let's just use the amount of premium. So 0.96 into the amount of annual premium, let's call it G, or you may call it P2, whatever you want, A due K x plus 1. Now x is 50, so let's write this again. This is 10,000 into V to the power of K 50 plus 1 minus 0.96 G A due K 50 plus 1. Okay, so this is my loss at time 0, and I'm calling it L0. Okay, so now what happens is, what we need is the amount of G from this equation, such that we need to find a value for G. Okay, what we need is G such that probability of loss, that this loss, probability that L0 is positive. Okay, if I'll have this positive, then only there will be a loss. So probability that there is a loss is less than equal to 0.05. Okay, so that's what I need. Okay, so the way we do this is actually very intuitive and very easy. Okay, so the next step, things change a bit. I want you to bear with me and understand. Okay, so what I'm doing here is, let's define a dummy premium, that is let's call that premium as Gn. So let G is equal to Gn. Okay, and let Gn be the amount of premium that is calculated as 10,000 into V to the power of n plus 1 over 0.96 A due n plus 1. Okay, so this is basically your premium if kx is equal to n. Okay, this is basically saying that this is your premium if kx is equal to n, that is if the person dies between time n and n plus 1. Okay, so you might be wondering, how did I get this equation for GN? Okay, let's discuss that a bit. See, what I did was a very simple thing. I just took this net future loss random variable at time 0, and I just put kx is equal to n. So I need the premium such that um, the person dies between time n and n plus 1, and I equated it to 0. So what I did was 10,000. I just put n in place of kx, so into v to the power of n plus 1 minus 0.96 into g into a due n plus 1, and I just put it 0. Okay, I just put 0 in place of it, right? So when you do this, you will get when you'll transform this, you will get g is equals to 10,000 into v to the power of n plus 1 over 0.96 a due n plus 1, right? So that's my gn. That's how I got gn. And then let's move further. So this is the amount of premium that I need to calculate. Let us call it gn. Okay, so gn is the premium that I need, and this would be the premium if this person dies between time n and n plus 1. And gn should be such that probability that loss is greater than 0, given that the premium is equal to gn. Okay, this probability, I want it to be less than 5%. Okay, so that's what I'm seeking. I just use this equation and I just assume that g is equal to gn. So gn is that premium for which the probability of loss is less than 5%. Okay, so that's my argument here. Now what happens is, let us check out this loss function. Okay, so what happens here is that if a person dies later than gn, okay, the probability of loss would be lower, and if he dies before gn, before time n, the probability of loss would be higher. Let me show it to you. Okay, let's say this is time n. Okay, so in case of a whole life assurance, always the company is benefited if the person dies later rather than sooner. Okay, if the person dies later, the later the person dies, the more is the amount of profit to the company. The reasons behind these are two. Okay, later death leads to two things. Okay, what does later death leads to? The first thing it leads to is more discounting of the benefits. Okay, so the present value of benefits is lower, so there is more discounting of benefits. The second thing it leads to is more amount of premium is charged. Okay, so for example, if of premium, for example, if I am if the person lives for 3 years, and if the person lives for 5 years, in such a contract, if he only lives for 3 years, he would have only paid three premiums at time 0, time 1, and time 2. If he dies before time 3, let's say if he dies before time 3, if he dies before time 5, he would have paid two more premiums at time 3 and time 4. So later the person dies, the more is the amount of premium collected, and more is the amount of discounting for the benefits. So our profit will increase if our probability of profit will increase if K50 is greater than N, and our probability for loss would occur if K50 is less than N. Okay, so probability of incurring a loss is just K50 being less than N. Okay, so that's our probability. Okay, so this probability can be written as probability that L0 is greater than 0, given that G is equal to Gn, given that G is equal to Gn, is just equal to the probability that a person lives till it that the person dies before time n. Okay, this is the same as this probability, because that is only when we incur a loss. If this person dies at time n, and we have determined the premium using time n, okay, assuming time n, there would be a zero probability, zero loss at time n, right? So at time n we have got a zero loss. If the person, if k50 is equal to n, then loss is equal to 0, right? If k50 is greater than n, then there would be a profit, okay, and if k50 is less than n, then only there will be a loss. So that's how you analyze it, what circumstances leads to what thing, okay. So in a whole life assurance contract, always if the person dies sooner, there is a loss, okay. So probability that we have a loss given that the premium is n is just same as the probability that the person dies before time n, right? So this must be clear to you by now. So this is the same as probability that this person dies by time n. So this is equal to Q50, NQ50, that is probability of dying by time n, okay. And this probability, what we wanted it to be was less than equal to 0.05. So that's what I need. I need probability. I need n. First thing that I need is n, and then I'll calculate gn using this n. Okay. So I need this n such that the probability of making a loss is less than 0.05. So nq50 is less than 0.05. Okay. So np50 has to be greater than 0.95, right? That's the exact counterpart. I just deducted 1 minus this thing on both the sides, right? So if n q50 is less than 0.05, then np50 is greater than 0.95, okay. So that's what I need. So this implies that L50 plus n by L50 is greater than 0.95, okay. So we need the least value of L50 plus n. Okay, we need the least value of L50 plus n such that it is greater than 0.95 into L50, right? Because we need the least premium here. We cannot charge a higher premium than this. So we need a least premium, and we need the least value for this L50 plus n. So this becomes L50 plus n should be greater than 0.95 into L50. If I check from the tables, is 9712, okay, 9712.4692, and this comes out to be L50 plus n is greater than, it is greater than coming out to be, okay, yeah, it comes out to be 9226.4692. So I need the immediate value from the L values which is greater than this value, okay. And it turns out that L60 is equal to 9287.2164, okay, and L61 is equal to 9212.7143, right? So what I want is to be greater than this, right? I want the L value to be greater than this. So the greater value is L60, right? That's what it is. So n is equal to 10. That's something we know now. Okay. And now the job remains is just to calculate the premium. So the premium amount would be G10, right? That would be 10,000 into V to the power of K n plus 1 over 0.96 into A due n plus 1. So this is it. So it becomes 10,000 into V to the power of 11 over 0.96 into A due 11, right? So this becomes, if you solve it, direct formulas, okay, this comes out to be 790. So that's your answer. So let's check out what we did here and give you an overview, okay. Let's check it out. So what we did was, see, they had given us the question that we need the least premium payable. Okay, they said we want the smallest level annual premium payable such that the probability of incurring a loss is less than or it's not greater than 5%. Okay, so what we had here was that loss is equal to, we defined the net future loss random variable. That's the first thing we did, right? Then what we said was we want this loss random variable uh, to be greater than 0, and this probability should not exceed 5%, right? So that's what we said. That was a criteria stipulated by the question. Now we said that the point where the premium is determined, okay, the value of kx for which the premium is determined, let it be n. Okay, so for kx is equal to n, the loss would be equal to 0, right? If we determine the premium using this criteria, exact criteria, then um, this means that the probability of loss at this point would be 0, right? The loss would be 0 at this point, right? So we just determined this dummy premium, right, using gn. Makes sense. Now this is just the probability that L is greater than 0, given that G is equal to Gn, this dummy premium, and this probability is to be less than 0.05. The next thing I told you was that in case of a whole life assurance, the sooner the person dies, okay, the probability of making a loss is higher, because for two reasons. The first reason, the later the person dies, the probability of making a loss is, we make a profit, right? And sooner the person dies, we make a loss. So for the reason is that when a person dies later, the death benefits are discounted more, and the amount of premium is more. Similarly, when he dies sooner, the amount of discounting is less. Okay, in case of sooner, we make a loss because um, the discounting is less and less premium is charged. Okay, so this leads to a uh, loss, obviously, because we have got less income, and the present value of the outgo is also higher, right? So this makes sense, right? So the probability of making a loss, given that the premium is n, is same as probability of dying sooner than n. Okay, so that means this is the same as probability that k50 is less than n, that is nq50 is and then we equate this to the probability. See, this was always 0.05, this was less than 0.05 as stipulated earlier, right? So I just equated it to this probability, that k50 is less than n, that is dying, the person dies before n, right? So this is, that's just nq50, that is less than equal to 0.05. So that just means that np50 is greater than 0.95. And then what I did was I applied the definition of np50. I used the tables to find the value of n. Then I just applied the premium formula and found the dummy premium G10, that now becomes my actual premium. So I hope this entire scenario would have become clearer to you. I am going to discuss one more question with you on this thing, and it would be 100% clear, right? Let's do that. Okay, so this is another question, very similar to the last one. Let's discuss this. Okay, so Hubert is age 60 and is applying to buy a whole life immediate annuity. Now this guy, he is buying an annuity. Okay, so immediate annuity means annuity payable in arrears, right? That starts immediately, obviously it's not deferred. So it's a whole life annuity for an insurance company with his life savings of 200,000. So he has got this life saving. This is his single premium that he'll be paying, and he'll be buying this annuity. Okay, calculate the largest amount of level annuity. Okay, so we need to calculate the largest amount of level annuity this time. Last time we had the smallest amount of premium, we need the largest amount of annuity here, that is payable annually in arrears. Okay, that the insurer could pay if the probability of loss under the contract is to be no more than 10%. So we cannot have more than 10% loss. Okay. The probability of the loss cannot be more than 10%. Okay. Yeah. So we have to take the mortality as PMA 92C20 and the interest is 5%. And there is a 1% expense on each annuity payment. So let's define the loss. So L0 in this case would be it would be the EPV of the annuity, okay, EPV of the benefit minus the plus the EPV of the expense minus not the EPVs, in fact the PVs, right? Because we are talking about the present value loss random variable. So these are the PVs, right? Not the EPVs. So the PV of benefit plus the PV of expense minus the PV of premium makes a lot of sense. So this one is A. The amount of benefit is not known. Let's call the benefit X. Okay, that's what they have used in your answer to. So let's call it that. This is A KX, right? This is payable as long as this guy is alive. Plus the expense is 0.01 X, right? It's 1% of the amount into AKX again. And the PV of premium is given directly. It is 200,000 pounds, right? So no doubt about that. Let's write it properly. This would be, these two would add up to be 1.1, in fact 1.01, because, right? And this is A K. What is the age of the guy? The guy is age 60 minus 200,000. Okay, so this is what I need, and obviously X, there is an X. So I need the value of X such that the probability that I need X such that the probability of this loss, okay, being positive is less than, is no, it does not exceed 10%. That's what we had. So it's less than or equal to 0.1, right? That's the deal. Okay, so let's give X a hypothetical value again. So what we'll call X is X equal to XK, or you can call it XP, XL, whatever you want. So XK would be equal to, it would be equal to 200,000 into 1.01 into A. Now in place of K60, I'll have a AK, right? Makes sense. What I did was, in this equation I just put K60 equal to K and then I equated it to 0, right? I equated the entire equation to 0, so you get this dummy premium, dummy payment. In fact, this is a benefit payment, not a premium. Okay, makes sense. So this is what I have, and at this payment the amount of loss would be 0. So now let us analyze what happens in case of an annuity. Okay, so your premium, it was fixed, so we don't need to worry about the premium. So at time k, okay, at time k, loss is equal to 0. Okay, if the person dies after k, if k60 is greater than k, then the amount of annuity payment to him would be more. Okay, so this would lead to a loss greater than 0. So this would increase the amount of loss. On the contrary, if I look at this side, if k60 would be less than k, then we would have a loss less than 0, or we would have a profit, right? That's what it would be. So if I talk to you in direct language, this just means that the more the person lives, the more would be the amount of loss, right? So the probability of incurring a loss is same as the probability of the person surviving more than k years. Okay, so that's what I'm saying here. So we need the probability that L0 is greater than 0, given that x is equal to xk, okay, to be less than equal to 0.1, right? And I am just saying that probability of making a loss is just the same as probability that k 60 is greater than k, and right, these two are same, because the longer the person lives, if he lives beyond k years, then only there will be a loss. So these two probabilities are the same, and I want this probability to be less than 10%. Okay, so now there is a catch. There is a little transformation that takes place here. See, what I have is the probability that k60 is greater than k is less than equal to 0.1, right? So this probability, this is the probability that the person survives for more than k years, like what it appears. And I have to write it in terms of the p probabilities. This won't be a q probability, this would be a p probability. And usually when we write p probabilities, they are in the form that kx is greater than equal to some k, right? Because they are the probability that a person survives for at least k years. So there is a greater than equal to sign and not a greater than sign. So we actually need to change this in terms of see, this is your definition for kpx, the probability that a person that kx is greater than equal to k. So there is always a equal to sign. So I need to change this in terms of the equal to greater than equal to probability. So for that we need probability k60 is greater than k. So what's happening here is k has to be, okay, k has to be greater than in fact k60 has to be greater than k. So the curate lifetime has to be greater than k. So this is the same as k60 being greater than or equal to k plus 1. I hope this makes sense to you, because see, the thing is that if k60 is to be greater than k, okay, so what's the next value for k60 after k? Okay, the next value is k plus 1, right? So to be greater than k, I can be k plus 1 or more. That's what it means, right? Because it can only take integer values. Curate lifetimes can take integer values only. So it can be greater than or equal to k plus 1. Okay, so that should make sense now. This is less than 0.1, right? So now this can be transformed in terms of the p probabilities. You have to be cautious about this. So the last time I had q probabilities. Q probability is just see, the definition of kqx is the probability that kx is less than k. So there is no equal to there, but there is a equal to here. So you have to be cautious about this, really cautious. Okay, or what you could have alternatively done is you could have deducted this from 1 minus this, and some sort of adjustment in order to transform this into q. Anyway, you would have to do this. So just try to understand this. Makes sense. Okay, so this is just k60 is greater than equal to k plus 1. So this becomes probability that a person age 60 survives for k plus at least k plus 1 years is less than 0.1, right? Make sense? Okay, so this becomes L60 plus K plus 1 over L60 is less than equal to 0.1. So L60 plus K plus 1 is less than equal to 0.1 into L60. So L60 is equal to, from the tables, PMA92 C20 is 9826.131. Okay, that's your value for K60. So now L95 is equal to 1020. Sorry, this value, it comes out to be L60 plus K plus 1 should be less than this comes out to be this multiplication. It is 982.6131, right? That's what it will come out to be. So from the tables, if I check the values closest to this, L95 is equal to 1020.409, and L96 is equal to 798.003. Okay, so these are your values. So I want it to be less than this, so obviously 96 would be applicable. Makes sense. So 60 plus k plus 1 is equals to 96. So the value of k comes out to be what? 35, right? So k is equal to 35. That's my final conclusion. And now I can calculate the dummy variable xk that I took. Xk would be equal to x35. That would be equal to 200,000 over 1.01 into a due 35 at the rate of 5%. So you have to calculate it at 5%. So this becomes 200,000 divided by 1.01 into 16.63742, right? So this becomes 12,093. Okay, so that's your answer for this. This would be your annual amount that you would receive in order to fulfill this profit criteria. So that's all I'm discussing for now. And I want you to try question number 7.8 by yourself. Okay, that's also a very similar question. There they've asked us to calculate the amount of reserve using a profit criteria. It's very same similar. Don't panic. Check out the solution if you can't solve it on your own. Okay, it won't make sense to you, I'm pretty sure. Okay, and go through this twice or thrice, this entire video, make things clear to you. This is one of the most complicated topics from the entire subject, not the chapter. Okay, just remember one thing, that for assurances we would incur a loss. The loss would increase if the person dies before time end. That is, if the person dies earlier. Okay, earlier the person dies, the more would be the amount of loss. And for annuities, it's just the opposite. The loss occurs if the person survives more. Okay, survival. And this happens for a very simple fact that if in case of assurances, what happens is if there is an earlier death, the amount of discounting is less, and thus the amount of benefit, the present value of benefit increases. But with annuities, if the person survives more, we have to make more number of payments. So it doesn't matter, even if the discounting is more, the number of payments increase, and that increases the value of annuities. And even for, if you think about the endowment part, we the amount of loss actually would increase if the person lives more, right? If he reaches the endowment date. So think about things like these. Remember these 2 points. Okay, these 2 points are very important, and otherwise it's easy. Okay, and the road ahead is very easy. In the next section we discuss the gross premiums, and then we move to gross reserves, and the calculation is exactly the same as net premiums and net reserves, except for the fact that they allow for expenses and bonuses and profits and things like that. So if you get to them, you'll find that they're like just the same thing all over again. You have to combine all the knowledge that you have gained so far. So thank you, give them a shot if you can on your own. Anyway, I'll be making a video, so that's there. I have all. Okay, cheers.